So this is a hint video for the trickier question. Now I'm going to break it down into a few bits and give you hints as we go. The order the question comes in doesn't actually necessarily make this easy. So when I'm talking through it, I'll actually show you that the way the questions are asked is not necessarily the easiest way to answer the question. So we're trying to find the equations of the radii AS. Now that one shouldn't be too much of a hassle because that's finding the equation of a line through 2 points. So A, and if we're finding AS, we could rewrite that question as find the equation of a line through 5, 7 and 4, 10. So that is a question that you should now be fairly comfortable answering, having done this week's work and having worked through kind of Nat 5 questions. That's something you could have met. I'm actually going to come back to talk about how we can do BL, because there's something we can find before BL. So SL, now that's this line here. Well, what key thing can we find? Well, if we find AS, we know its gradient, and we know that SL is perpendicular. Use perpendicular gradient to AS. So the gradient AS, sorry, my quality seems to have gone down. Just let me focus a little bit better. So the gradient AS is something we found up here, and then we can use that gradient, the perpendicular gradient to that, to find the gradient of SL, and then find line equation through, now we know the coordinates of S, so it's a line equation through 410 with that perpendicular gradient that you've found. So that's how you're going to work on SL. We can actually then use this idea to help us think about BL. Now you know that if this is a right angle and this is a right angle, then this line here and this line here are parallel. So MAS is equal to MBL. So because they're parallel, we know those two gradients are the same, and then we can do a very similar thing down here. So we can find line equation with gradient MBL and point. Well, we know it goes through the center of the circle here, which is B, so it goes through the point 15, 7. So actually, lots of thinking involved to work out what information you do have, but once you have that information, hopefully you can see how to kind of put it all together with the skills that you have. AB, well, we can simplify that question down quite a lot. Just splitting this off so you can see. Find the line equation through. Now we actually already know the points A and B, so that one isn't too hard. So it's a line equation through the point 5, 7 and 15, 7. And a little bit of observation, I'll tell you, it's actually a horizontal line. So we'd expect it to have an equation y equals something. So actually you can almost write that down. If you think about your diagram carefully enough, you don't need to do any maths to do that. You can almost write it down just from knowing the coordinates. If you end up doing a bit more maths, no harm done. Now, the last one, and this is definitely the trickiest one, is thinking about this line here and what we know about it. And thinking about maybe what we know given that line of symmetry. Okay, so first thing we know the coordinates of S are 4, 10. We're told this is a line of symmetry, and the height of A is up by 7 units. So we've got kind of a vertical distance here of 3. So if it's a line of symmetry, the point S must be the same distance left or right, but it must be 3 below the line. So that tells us that this point here is the point 4, and it's 6 below this one, so 4, 4. Symmetry, we can do exactly the same trick here, except we don't know the point L, so we can't actually quite use that to help us. What we could use is a very clever little trick, and this is something that will always work. We haven't actually mentioned it before, but if this is going uphill with a gradient of, say, a half, and I reflect it in this line, which is horizontal, only works if it's a horizontal line, and I reflect it down here, instead of going uphill with a gradient of a half, it will now be going downhill with a gradient of a half. Now that's a clever extra trick that we can use in this very particular situation. So this is quite a tricky question because you haven't met that idea before. So hopefully now kind of seeing that it makes sense. If I was going to convince you of that fact, gradient is how far you go up over how far you go along. Here, the along doesn't change, but because we've reflected in line of symmetry, we're now going down instead of up. So we're going to get a negative instead of a positive amount. And so we can see the gradient remains the same, but it's going to be negative. So let's write all that down. So we have m of s dash l dash is equal to minus the gradient SL. And we have point S dash equals 4, 4. Using those facts, we can then find the equation of the line because we know its gradient and we know a point on the line. And once you've got that, you can find a line equation. So there's quite a lot of thinking involved in this question. But if you've managed to follow and kind of see through what I've explained there, the rest hopefully is just using the skills that you know. Have a go. Well done if you work your way through this. There will be a full work solution that I put up tomorrow. It's going to be quite lengthy for this one, but if you're interested and you work through it, the full work solution will be there.